Hey math kids, today we're going to talk about instantaneous rates of change. And I touched on that for a second in the last video, but essentially, if we have a curve, we can find an average rate of change. We pick 2 points and find the slope of the line segment that connects those 2 points. Now, if we take these points, or let's say this point is movable, if I start getting that closer and closer and closer to the original point, and so close that they become infinitely close, then the slope of the line is going to be the slope at that point. And that's what an instantaneous rate of change is. It's just when we get those 2 pieces and we move them infinitely close. Okay? And so one way we were thinking of a rate of change is like the difference between this x value, oops, it's not an x, and then the difference between the y values of the 2 points. And so if we just make that x value infinitely small, then what we create is a derivative, or an instantaneous rate of change. Okay, so there's only one example. Let's just do it real quick. It says, use the tangents drawn to find the instantaneous rate of change in y equals f of x. Okay, so in your book, there's going to be a better drawing than this, but they have a point at 2, and they have a curve that goes through 2, and then there's a tangent line drawn at that point. And then we also have b, which is over here, and it's 4, 5, 6. So right here is 6, and negative 1. Okay, so just to be clear, this point is 0, 2, and this point is 6, negative 1. Okay. All right. Now, all we really have to do is find the slope of this line. And if we look further on the graph, we can actually find these 2 points, and those are going to be the ones that are a little more helpful. So this is at negative 2, 0, and this point is at 2, 4. Okay, and so if we can just use that slope equation. So I'm just going to say that this is x2, y2, x1, y1, and remember it's y2 minus y1 over x2 minus x1, and this is going to give us the instantaneous rate of change because it is the slope of a tangent line. Okay, so if I plug in y2, I get 4, y1 is 0, x2 is 2, minus a negative 2. So the top becomes 4, 2 minus a negative 2 is like adding, so that's 4. So overall, the instantaneous rate of change at that point is 1, because the slope of the tangent line is 1. Now we're going to use a similar method for the tangent line that's drawn right here. The endpoints that we can see that are useful, let's see, 4, 5, 6, 7, negative 3. And then the one that's up here is going to be 5, 1. So once again, I'm just picking points that it goes right through the corner of the grid to make this easier. So I'll call this one x1, y1, x2, y2. It doesn't really matter which one I choose as 1 and 2, but just as long as we're consistent with when we plug it in here. So y2 is 1, y1 is negative 3, so we subtract a negative 3, and then x2 is 5, x1 is negative 7, so we add these together, we get 4 over negative 2, which just gives us negative 2 when we divide those. And so once again, the slope of the tangent line at this point is -2, and so that is also the instantaneous rate of change. If you need additional help, please come to Math Lab. Until then, calculate.